Hello, guys, this is an installation, and this is just 2 class. It's good to be back here again. I believe you are keeping safe at home and doing the necessary things like solving assignments, providing solutions to assignments given, reading your notes, and other things that pertain to academics. The last time I was here, we discussed about bearing and distance, and I told you all about the concept of bearing, the shapes by which how you draw your bearing, the poles, the cardinal points that we have. We have 4 cardinal points. We have the north, the south, the east, and the west. And the cardinal points between what are poles. And we have the northeast and the southwest, southeast, and the rest. And I told you how you start from the what your north and the south. You don't pick east. No, there's nothing like east, north, or west, south. It has to be from the north or from the south. So and there are 2 types of what bearing, the compass bearing, and the three-figure what bearing, the compass bearing. You calculate it and the three-figure bearing. I told you if you have to figure like a 65 degree, if you are using three-figure bearing, you add an additional zero at the back of it to make it what three-figure. So we talked about that, and we talked about how you can use the scale drawing to what calculate your what distance between 2 what points of their with different bearings. So, but today we'll be looking at under statistics. We'll be looking at data presentation. How you can represent your what informations, your data in an orderly manner, in a frequency table, in pictorial form, and the rest. So, but I'd like to take you through the learning objective. Take you through the learning objective. What we set to achieve today. So, this is the statistics data presentation. So, our learning objective. So at the end of the lesson, students should be able to, one, present data in an ordered form and in frequency table. When you're talking about ordered form, it means the data you're talking about that we are about to be processed is in what in is not in an orderly manner. That is in a random form, is a scattered form. So those kind of data that are not in an orderly manner, we call them what raw data. We call them raw data. Data that are not well arranged, and there are by several ways that we can arrange data. I will look at that as we go on in the topic. And in frequency table is another way by which is another manner of arranging what data. But you just prepare a frequency table, you put your information, and you get your frequency from that data given. Number 2, present statistical data in pictorial form. In pictorial form, when you're talking about pictorial form, is another word for saying diagram or picture. And another is in a picture form, e.g., pictogram, bar chart, pie chart. We'll explain further that and how you can interpret your what pie chart. How you can interpret your what pie chart. These are 3 ways that which we'll be looking at in a pictorial form, how you can represent your what data in an orderly manner. So let us go to how you can arrange your data in an orderly form. So presenting data in ordered form, presenting data in order form, data which have not been processed are called raw data. We say data which have not been processed, scattered data, arranged randomly. They just scattered or are just placed in different positions, not in a what sequential manner. They are called raw data. While when data are given, it is important to arrange them in a what orderly manner for easy understanding and interpretation of information contained in them. There are ways by which you can arrange it. Let me take for numbers. Let me take for numbers. It can be given numbers like let's say 13, 17, 21, 88, 105. You can see they are just scattered. They are in a random form. They are not in an orderly manner. You can't just pick like this is how it is being arranged. No. So, but there are ways by which you can arrange this data in an orderly manner. And one, we can say you can arrange in an ascending order. When we mean ascending order, you say in an increasing form. If I just pick numbers from 1, 2, 3, 4, 5, and see the way they keep increasing. Or in a descending order, whereby you just come from in a decreasing form, whereby it comes from 10, 9, 8, 7 down to 1. I say there's a pattern to it. There's a pattern of what arrangement. So when I just pick 10, 11, 14, 17, no, that is not, they are not well arranged. They will call those kind of data raw data. And on raw data, it is hard to pick information. So it is hard to interpret those kind of information. But for understanding of that kind of information, it is hard. But when you arrange data in an orderly manner, yes, easy understanding and what interpretation of information will be achieved. So data can be presented in different forms. Data can be presented in different forms, that is numerical, alphabetical, or in order of what magnitude. It could be in numbers, like I said, I was explaining 1, 2, 3. It can be presented in a numerical order or in an alphabetical order like A, B, C. Not like we have the numbers, you arrange the alphabet like Z, Q, A, D. No, in a disarray manner. No, has to be in a what orderly manner, or in order of what magnitude. It could be by sizes. You can say this ball is 2 kg, the next ball is 4 kg, the next ball is 6 kg. Then they are arranged like that in a sequential what manner. So these are the ways by which data can be presented in what in an orderly form. So we look at the next. Let me take an example on the presenting data in another form. So look at this example. The shoe sizes of 20 boys. We have 20 boys putting on different shoe sizes as follow. 8. Look at this information very, very well. Look at this data. 8, 10, 9, 10, 11, 9, 8, 9, 12, 9, 10, 9, 9, 8, 8, 9, 10, 10, 9, 11. They are in a what? Disorderly manner. They are not well arranged. They are not enough because you can't just pick a pattern of what arrangement. 8 is less than 10 years, but 10 is greater than 9, and 9 is less than 10 again. 10 is less than 11, 11 is greater than 9, 8 is less. You can see it's in a what? It's not in an they are not well arranged. So you just say, and the question says, arrange the shoes in what ascending order. I told you ascending means in an increasing what form. Why that is you pick from the least number to the what highest number. Pick from the least to the next least. No, sorry, to the next highest, to the next highest, till it gets to the what highest. While number 2 says in descending order, that is from the highest to the lowest. It keeps decreasing, it keeps decreasing, it keeps decreasing. You pick the highest, then the next lowest, lowest, the lowest, the lowest down, so you get to the what final lowest. And number 3 says which shoe size is the most common among the boys. That is the shoe size that most of the boys wear most. The shoe size that is common among them. Is it the shoe size 9? Is it the shoe size 8? How do you look at these? It's the shoe size that is common among the boys. And number 4 says how many boys wear from shoe size 10 and above? From 10, how many boys wear from shoe size 10 and what above? So let us look at the increasing what order. The least number here is what 8. So we pick the numbers that are 8. We 8, 8, you arrange them, and the next highest number is what 9. Like more than greater than 8 is what 9. Then you go with 9. The next thing is what 10. You go with 10. The next thing is 11. You go with 11, and the next thing is what 12, which is the highest. So from the least to the highest is called what the ascending order. So we want to pick from the ascending order. We pick from the highest 12 down to what 11, down to what 10, down to 9, down to 8, and down to, which is what the lowest number. So let us look at the solution. So the solution is the data presented are in the form of numbers. They are in numerical form. Like I said, it could be in numerical form. It could be in alphabetical form. It could be in what else, depending on the magnitude or the size of the what data, the way you arrange them. So this one is a numerical what data. So and raw data, as the data presented in the form of numbers and raw data because they are not arranged. I told you raw data and data that are not what arranged. So our ascending order means data should be arranged in and what increasing order, that is from 8 down to 9, down to 10, down to 11, down to 12. You can see 8, 9, you arrange all the 9s, you arrange all the 10s, and you arrange 11s, and you pick the highest number, which is 12. So the descending order means that data should be arranged in a decreasing order, that is from the highest number down to the lowest, down sliding. From the highest to the what to the lowest, coming down. So it is well arranged. So it is easy to pick the question 3 and question 4. But when data are well arranged, information will be what easily interpreted, will be easily deducted what from the what data. But when they are not arranged, it will be so hard to get what the necessary information. Looking at this now, the most common shoe among the boys is what 8 is just 1, 2, 3, 4. 9 is what 1, 2, 3, 4, 5, 6, 7, 8. 10 is what 5. 1, 2, 3, 4, 5. Why 11 is what 2, 12 is what 1. So obviously the most common one you can see is what 9. The shoe size that is common among the boys is what 9. So you can easily pick your information of what after what data are well arranged. And let's say we question says how many boys wear from shoe size 10 from above? How many boys wear from shoe size 10 and above? How many boys wear size 10 and what above? So just from your orderly arrangement, so you pick from what this is 10. The list number is 10, then you count 1, 2, 3, 4, 5, 6, 7, what? 8 boys wear shoe size from 10 and what above. So you can see it is easy when you have arranged your data in an orderly manner. Information will be easily deducted. Better understanding of the information and what interpreting the information will be what very, very easy. So in any data you are given, first thing you do is that you arrange them. You arrange them in a what in an orderly manner. You arrange them in an orderly manner. So we'll go to the next thing, which is what presenting data in a frequency table. This is another way by which you can present your data. I told you earlier in an orderly manner, you have the ascending, it could be ascending order, it could be in a descending order. Understand? So you have to arrange them in another. So a frequency table is always another way of representing or presenting what information. can present your information in a what in a frequency what table for easy understanding and interpretation of what information contained in them. So this is how you present your what frequency table. Probably more we'll talk more about the tally, but this is let me just take you through it. Like look at this now. This is what information data. How many times does 4 appear? Twice. How many times does 5 appear? Twice. 6 appeared 4 times. This is frequency. 7 appeared 5 times. 8 appears 4 times. 9 twice and 10 once. So in doing this is how you prepare the tally table for your frequency what table. This is 2, 1, 2. This is 2, 5 appeared twice, 1, 2, 6 appeared 4 times, 1, 2, 3, 4. So this is how you arrange what prepare 5 in what tally. 1, 2, 3, 4, then you cross it. Given what this a whole of this is what 5. And since different from 4, 4 is not crossed, but 5 you cross it. Gives you have information like let's say 7, you have 1, 2, 3, 4, 5, you cross 5, then you have your 2 again. 1, 2. So that's how you represent your information with on tally. 8 is what 4, 9 is 2, and what 10 is 1. So this is how you present that in what in frequency table. It's another way of what representing what or presenting raw data for easy understanding and interpretation of what information is contained in them. So this is an example of what a frequency table. So we'll go to the next step. Pictorial representation of what data I already told you. Pictorial is something let's say diagram or picture. Picture representation of data. How you can represent your data in what in a diagram form is what we are looking at here. And there are 3 ways basically. We talk about the pictogram, we talk about the pie chart, bar chart, I'm talking about the pie chart. So we take it like that as in the sequential manner from the pictogram to the what to the bar chart and to the what pie chart. Data can also be presented in a picture or diagram form, and this includes the pictogram, bar chart, and pie chart. Data can also be presented in a picture or diagram form, and this includes a pictogram, bar chart, and what pie chart. So pick the pictogram. Let me explain this to you. This is used to present data that can be what counted. Data that can be what counted, like number of students in the school, the number of chairs in the class, the number of systems in the ICT, the number of tables in the class, the number of shoes student. You understand? Numbers that can be what counted. These are information that can be what easily counted. You can use a pictogram to represent the kind of information. But in pictogram, a simple number of identical drawing, when you mean identical that the same drawing or picture can be divided into half or something quarter may be used to show the data. May be used to what show the data. You can pick a picture that can be divided into 2 or 3 to show a data to represent what an information. So let me take you through this. I will explain that in this example. Look at now. This is a varieties of apple in the food store. So they've taken one apple, the picture of what one apple. You know, we're talking about pictogram representing information in what in picture form or diagram form. So they've taken the picture of one apple to represent what 10 apples. 10 apples. I know you told you pictogram is used for what information that can be counted, represent data that can be what's counted. So in this case, the one apple picture of one apple is used to represent what 10 apples, and half of it automatically is what divided by 2 is what 5 apples. So we have this kind of diagram in the information. You know this is 5, and one whole apple represents what 10. That's why the information said in pictogram a simple number of identical drawing or picture which can be divided into half or something quarter may be used to show the data, which can be divided into 2 or quarter may be used to what to show the data. So in this example, one apple is used to represent what the information of what 10 apples. Just one picture of one apple takes what 10 apples, while the half of the apple takes what the what 5 apples. So look at the table says varieties of what apples in a food store. Varieties of what apples in a food store. This is the food store now. This is the number of apples in the food store. So how many red delicious do we have in the store? We have what 30. We just have what 3 pictures here. So you'll have known that one picture of an apple represents what 10. So we have 30 red delicious what apple in the what food store. Now this 10 plus 10 plus 10. This is what 30. How many golden delicious do we have? We have 25. That is 10 plus 10 plus 5. Half of these represents what 5 apples. How many red rooms do we have? We have 40. 10 plus 10 plus 10 plus 10. 40. How many Macintosh? We have 20. 10 plus what 10. How many Jonathan? We have what 35. 10 plus 10 plus 10 plus 5. You can see. So this is how you represent what information in a what in a pictogram. This is how you represent in a what in a pictogram. Yeah, you represent data that can be what that can be counted, and that you can divide one information to represent what several what informations in the what in pictogram. So we'll go to bar chart. So in bar chart, a bar chart, let me just take a note for you. A bar chart can either be drawn in a vertical manner. You know what a vertical manner is, straight down, a vertical manner, or in an horizontal manner. An horizontal manner is a cross line. So a bar chart consists of bars, that is information are represented what in bars. You can say from the name bar chart. a chart, bar. So they are represented what in bar, and consist of bars with the same width, the same base. The bars that are represented, they have four informations that are presented on the bar chart. Those bars have the same what base, they have the same what width, they have the same what breadth. So a bar chart consists of bars with the same width, and bars are always separated with what by equal width. That is the separation between the what the four informations, the distance between them, the differences of their width has to be what the same. From bar one, the distance, the width between what bar one and information two has to be the same one between what bar two and bar three has to be the same one between what bar three and bar four. While you have to consider the bars, the width of the bars, the same drawing. It's not like one will be bigger than the other one will be smaller. No, the same bars must be what used, but the height of the bar depends on the frequency of the what each value. Like let's say you have four informations now. The height of the bars doesn't they are not equal. It depends on the what the frequency of the what the frequency of the table, the frequency depends on their frequency. So the height depends on their what, the frequency of what each value. Information one can be what 100, information two can be what 80, information three can be what 60, while information four can be what 40. So their height now depends on their what frequency, how high they go in the on the bar chart depends on their what their frequency. Let me take you through this example. So the bar chart below shows the number of students in the what in a school. The bar chart below shows the number of students in a school. The bar chart shows the number of students in the school. Use the bar chart to answer the following questions. So they are giving us a question. So we interpret what the bar chart given. How many students? How many more students? So let me show you the bar chart. So this is the bar chart given for the question. That's it. So how many more students are in JSS classes than the SS classes? You have to always consider your questions very, very well. Know what every question means. That is, how many more students? That is, how many students are in JSS class? How more are they than the SS class? That is, the number of students in the SS class, junior classes. How more are they than those ones in the SS classes? By what numbers are they more than the what students in SS classes? Number two says, what fraction of the old school is in JSS one? That is the old school, the total number of the old school. So what is the fraction of the number of students in the class? What SS1? So that's what we are looking at. Then number three says, what percentage of students are in what SS3 class? What is the percentage of what the SS3 class from the what old school? So let me take the diagram to explain what the notes earlier. Look at it now. Look at the width of what this is for is 6 information of different what 6 classes. So look at the width of JSS1. It's the same as the width of what JSS2. Down to what SS3. The bars are of what different of the same what size. The same what thickness, the same size. Not that the information in JSS1 is thicker than that of JSS2. No, there has to be the same. In bar charts, you have to consider this thing. And the distance between them, the width between them, I say between JSS1 and JSS2, is the same as that of JSS2 and JSS3, JSS3 and SS1, and SS1 as down to what SS3 is the same what the same width, but the height depends on what the frequency. You can look at JSS1 now is 100. It's more than that of what JSS2, which is what 90. More than what JSS3, which is what JSS3, which is what 80. SS1 is also 90. SS2 is also 80, while SS3 is what 60. You can see their height depends on their what their frequency, how much how they occur. Their height depends on their frequency, but their width has to be what the same what all through between the distances. So let us look at the number one question. Number one question says, how many more students are in JSS classes than the SS classes? How many more students are in JSS classes than in SS classes? That's it. By which number is the junior classes more than the what SS classes? By which number? You can see now we have what? How many students in JSS1? We have 100. How many students in JSS2? We have 90. How many students in JSS3? We have what? 80. So the total number of students in JSS classes is what? 100 plus 90 plus 80, which is what? 270. While the number SS class is what? SS1 is what? 90. SS2 is what? 80. While SS3 is what? 60. So they have 90 plus what? 80. 170 plus 30 is what? 230. You can see that 270 in what? Junior classes and 230 in what? 270 in junior classes and 230 in what? Senior classes. So that's how you do it. So by which number is it that the junior classes are more than the what? The senior classes. So let us look at the solution. Solution 1 says the total number of students in junior classes is what? 100 plus 90 plus 80. That's look at the diagram. 100 JSS1, 90 JSS2, 80 in JSS3. And number 2 says the total, which is got to what? 270. The total number of students in SS classes is what? 90. SS1 is 90. SS2 is 80. While SS3 is what? 60. Which will now give you what? 230. So the question 230. So therefore, the number of students by which the junior classes is more than the SS classes is what? 270 minus 230, which will give you what? 40 students. Can say it is easy to interpret when you present your data in an orderly manner. In a bar chart, you can easily get the information, interpret it, and understand what the information provided. So number two question says, what fraction of the whole school is in what JSS1? By what fraction of the whole school is in what JSS1? The bar chart, JSS1 is what 100, and we have the total number of students will be what junior classes is 270, while junior classes is 270, senior classes is 230. 270 plus 230 will give you what 500. So we have what junior class will be what 100. So what fraction that will be what obviously what JSS1 over the what total number of the students, which is what 100 over what 500. That will give you a fraction of what 1 over 5. You can see the total number of students in what okay. The total number of students is 270 plus 2, which is 500 students. So fraction of JSS1 in the school is what 100 over what 500. From the information, the number of students in JSS1 is what 100 and over what 500, which will give you what 1 over what 5. Number three question says percentage of students in what percentage of students in what percentage of students are in what SS3. Total number of students in SS3 is what 60, and that's 60 over what 500 times what 100 to get the percentage. So which will give us what 60 over 500 excuse me times 100, so give you what the percentage of what 12%. That is 12% of SS3 out of the 100% in the whole school. The total number of the whole school is what in percentage is 100. So 12% SS3 only occupy what 12%. SS3 only occupy what 12%. If you want to try more questions, you can look at the percentage of the students in JSS1 and look at the percentage of the students in what JSS1, which will give you about let's say 20%. Can look at the percentage of students in JSS2, JSS3, and accumulate everything to give you what 100%. That is that about bar chart. So we'll go to the next thing, pie chart. So this is another form by which data can be presented. I told you earlier we can present data in in pictogram form, and we explain the picture and bar chart. So the last one is the pie chart. So that this is another form by which data can be presented. Pie chart can display in a circular form and shows the division of data in sectors. In bar charts, they are divided in what bars. They are divided in what bars of different heights depending on their frequency. But in pie chart, it's a circular form of representing what information or data, and all this information are divided into what sectors. In bar chart, they are divided into what bar, and they are different between what the distance between them is what as equal width and the other properties like that. But in bar chart, in pie chart, all the information are in a circle, but different data are represented in sectors. Each sector, depending on the number of information you have. Depending on the number of information you have. So I'll explain through this example pie chart. So look at this now. Example, in a university department, there are 180 students. There are 180 students from different states as follows. These are the total number of students is what 180. Student from Edo is what 45. From Ekiti is what 35. From Ondo is what 40. From Delta is what 20. From other states is what 40. Delta is 45. Ekiti is 35. Ondo is 40. Delta is 20, and others is what 40. So the total number will be what? This is 45 plus 35. That's 80, 120, 160, and what? I'll give you what 140 and 180. So you have what the total number to be what 180. So in a university student in department, there are 180 students from what different states are follow. There are 180 students from what different states as follow. So in Edo we have 45, Ekiti we have 35, Ondo we have 40, Delta we have 20, and others we have what 40. So present the information in a pie chart. So we are how to represent this in a pie chart. You should know that the total degrees in a circle we are talking about circle is what 360 degrees. So all this information has to be broken in degrees. That's why we said they are broken into what sectors in degrees. They are broken into what in sectors. So every information has to be add every information together. You have to get to the 360 degrees. So we have find the fraction of number 2 says find the fraction of the students that are from other states. Number 3, what's the percentage of the students from Ekiti? Correct to one decimal places. So first thing we have to represent the data in a pie chart. So if you want to break it in pie chart, you have to first get your degrees accurately. Number 1, Edo is 45 students. The total number of students is 180, and there are 360 degrees in a circle. So we need to find the angles of each state in order to draw the pie chart. First thing you're going to do, you have to find the angles of each state. Each number over the total number times 360 will give you the sector of each information. So for Edo, there are 45 students. It's 45 over 180 times 360 will give us 90 degrees. You get your 90 degrees straight. Ekiti is what? 35 with the substrate again, you have 70 degrees. Ondo is 40, you have 80 degrees. Delta is 20, you have 40 degrees. Other is what? Other states. People from other states, probably like Kaduna, Kano, that's what they are representing here. They accumulated accumulate all together and give us what? 40 students from other states to give what? 80 degrees. So you divide all these degrees. 90 plus 70 is what? 160. 160 plus 80 will give you what? 240. 240 will give you what? Plus 40 will give you 280. And 280 plus 80 will give you what? 360. So you have the sum of everything to what? 360. Then you now break it into what? Into what? Pie chart. So this is the pie chart. So you can see Edo 90 degrees, Ekiti 70 degrees, 80 degrees, 40 degrees, and what? 40 degrees. So you bring your what? Out your what? Protractor in case you want to draw it perfect. Bring out your what? Protractor and draw what? Equal angles very, very well. So these are your present. This is a pie chart in a circular form, and their information are broken into what sector. You can see the sector of A colored what blue, sector of this with another color, with another color, with another color, and with another color. So that's how to represent the information in a what pie chart. So we represent the information from the question given says number one, represent the information in a what present the information on a pie chart. So that's number one. Number two says find the fraction of students that are from other states. The fraction of students, like we did in our bar chart, it will be what? This is the number of students from other states over the total number, which is what? 40 over 180. So that is easily done. We have what? Fraction of students from other states, what? 40 over 180. If you divide through, we have what? 2 over 9. Your answer has to be in a what? Fraction form, because the question says fraction of students from what? Other states. It's 2 over 9. And number third question says percentage of students from Ekiti. What is the percentage of students from Ekiti? What? 35 over what? 180 times what? 100. To get the percentage is what? Over what? 100. Only if you want to get your pie chart, that's when you're using what? 360 degrees. So it's 35 over 180 times what? 100 to give you 19.4%. So that's that about how to represent information or data in what? In pictogram. We have that. We've talked about the pictogram in pictorial form. So we talked about the pictogram, talked about bar chart, and we talked about what? Pie chart. And first thing, you have to know how to arrange your data, probably in ascending order, descending order, but all data must be what? In arranged order. So we've come to the end of today's class. You can go to your online notes center questions there. With this explanation, I believe you can what? Attempt all questions now. Just apply every rule to every question, and I believe you'll get your solution right. Thank you. I'll see you in the next class.